Okay, I think I don't see anybody else, but there's somebody else popping on. Okay. I think I'm gonna go ahead and get started because I got a pretty tight schedule to follow. So hi, everybody. Most of you know me. We are recording this, so whenever we're done with tonight's session, I'll send out a link to the recording from tonight, and same thing with tomorrow. The reason we're doing this is because in the past, a lot of people go into our first semester stats course without ever having seen R before, and it can be kind of a very precipitous learning curve. And so I was talking with Dr. Joyner about what we could do to kind of ease that learning curve a little bit by showing you some fundamental parts of R, getting you started, installing it, using the standard interface called Rstudio, and then going through some basic data descriptives, plotting, and use of something called the tidyverse, which is a suite of packages for R to do data manipulation and data summaries and things. So I'd like to introduce a few people before we start, though. If you wouldn't mind saying hello, Sarah Charmin. Sarah is
hi. Yeah.
So most of y'all met Sarah last night. She's in Pennsylvania right now. Sarah is a third-year student in the program now, and I've asked her to come along because she's used R for a couple of years. Scott Craig, would you mind saying hello?
Hello, Scott.
Scott has a master's in statistics from UTSA and has done several data science projects with me using some really messy data in R, and has taught me several things about R along the way. I'm thankful he's a, what year are you, Scott? You're a 3+.
I think as you turned it last night, I'm a 3+.
You're a 3+. Very good. And Samson, would you mind saying hello?
Hi, everyone. My name is Samson. I'm a second-year PhD student.
I have forced Samson to use R every week throughout the past year, and he has come through swimmingly and has learned a lot and made some wonderful figures for our publication that we're working on right now. In addition to munging millions of lines of administrative data. So I've asked these three to come on board tonight, primarily to help me keep an eye on the chat. So feel free during the presentation, if you have a question, ask it in the chat. I may answer it, but I typically get lost when I'm talking, so I may not answer it, but please, Scott, Sarah, or Sam, if you see a question in the chat, would you kind of jump on it? I welcome people to stop me and ask questions. This is not an economics lecture. You can stop me anytime and ask a question. I encourage that. If you're unsure of something I'm talking about, please ask a question. We're going to be covering a lot of ground, but it's fundamental stuff. We're not going to jump in too deep to start off with. As I mentioned in the email I sent out to people, we're going to be using a data set tonight. I'll put that in the chat too. It's the World Population Data Sheet. It's a data set that the Population Research Bureau puts out every year. They usually put it out as a publication. And there we go, I'll put that up there. This is one from 2008. This is Population Reference Bureau is a non-governmental organization that keeps track of lots of population trends. You'll probably see some of the materials in Dr. Science's class. They put out lots of like policy briefs related to current demographic problems that are going on in the US and worldwide. And this is a data set that they use a lot to do population summaries. It's for nations in the world. It's smallish. It's for every country in the world. So it's only about 200-ish rows of data. and it's got a lot of fundamental demographic indicators in it. We're going to use that as like our data set we're going to be tinkering with tonight. So unless there's anything to get started with, I'd like to go ahead and get started with the presentation. So again, if you have any questions along the way, just say hey and stop me. So these are the notes. This is the file that should have come through in the chat just now, or the file that I emailed you earlier. This should open up in any web browser. You're all here, so the Zoom link must have worked. This is made in R. So all of my notes that I do for all my classes are written in R, but that's not what we're going to be learning tonight and tomorrow. We're going to be learning fundamental parts of using R for basic data analysis, okay, and getting it installed. So what we're going to do over the next couple of days is do a short introduction to the R statistical programming language. And again, I'm intending to do this to try to ease the anxiety over using R in your stats classes. And I mean, this is the software that we teach in the program. You use it for stats, you use it for GIS, you use it for more advanced statistical techniques that you'll be exposed to in the program. This forms the core of the statistical education in the program. It's not the only thing out there, but it is one of the most in-demand skill sets in the applied market. This and Python are probably the two programming languages that if you were to learn something, and SQL for databases are things that can get you a nice job immediately, even before you finish your degree. So it's really in demand, but it can be very foreign to a lot of people coming to it for the first time. And I realize not many of you may have never seen R before, so that's the reason why we're doing this, is to kind of show it to you before you actually have to start using it next week. What I hope you'll get from this is I want to get R and Rstudio set up on your personal computer. If you're familiar with installing software, this is not a heavy lift. It involves installing a couple of packages on your computer. We'll walk through where to get those and what those look like, and get you oriented with how to use those things. This is what we're going to be spending the largest part of tonight on, is going through Rstudio, the development environment for R, because it has a lot of neat little tools that are very useful. So a little bit of history lesson. Before R, there was a language called S, and it was invented in Bell Labs, probably in the late 1970s, early 1980s. Starting in the early mid-1990s, a couple of statisticians at the University of Auckland in New Zealand, Rob Gentleman and Ross Ihaka, invented the R language. S was this language you had to pay like thousands of dollars for. It's like SAS. It was expensive. It did lots of wonderful things, and it did them quickly, and it was easily added on to, but it was expensive. So they ported this really expensive software into R, that was their sort of thing. It was R isn't S. And so that's where R came from, was from these people. And early in the 1990s, I first saw R in I first saw R in probably 1999. It was before version 1. I had a very early adopter advisor who was really into using open source software. And so I've been using R for a long time now, and it forms the basis of everything that I do. So it's an open source software system, meaning that you can go see the code that makes everything work. The building blocks for the whole program are freely distributed and modifiable by anybody who wants to come in and use that. And so what's happened is people have done so. It started out as a very small suite of packages for basic graphics, basic statistical analysis, some basic data management skills. And since then, R has grown into an ecosystem that now includes over 18,000 user-written packages that do a variety of different tasks. And these are written by people like you and me. These are written by grad students and professors and people that want to do method X on data set Y, and this software doesn't exist. So they go out and create a package so that then you and I can get access to their cool techniques that they're inventing. And that's really the thing that R has an advantage over in terms of other statistical packages. Is it's at the bleeding edge of development for new methodologies. So anything new that's coming to the line from mathematicians or statisticians or any sort of data science people usually goes to R first. I've used R for about 20 years. I was trained initially in SPSS and SAS, but quickly these two fell by the side, basically because R was much more flexible and nimble in terms of what it could do. And since I arrived at UTSA, R has been basically the only software that I've used, unless it's a special occasion. Like this morning, Rogelio and I were working on something and I used SAS, probably for the first time in a couple of years. It's still there somewhere. But yeah, R is fundamental to what I do. Okay. Python is also a very useful language that a lot of people use in data science, but it's not really taught in social science. It's much more the computer science side of things. If you have the means and you have some spare time on your hands, it probably wouldn't hurt you to learn some Python. I find Python to be excruciatingly frustrating because simple things are very challenging to do in Python. And things that have beautiful functions for are much more complicated to do in Python. Python is better for data manipulation, complex data manipulation, but R is much better for statistics and data analysis. Why do I like to use R? And why do I try to convince people like you to use R? First, it's free. It doesn't cost you anything. Students especially have a very limited budget. So why would I force you to buy software if you don't have to? R will do everything that the other statistical packages cost, that costs anywhere from $50 to $2,000. You know, this is something that you can do everything they can do for free, plus some. So why would I pass along cost to students? Second, it's the hotbed for methodological development. It's where most statistical research and data science research is being done. It's being done in R, primarily because you can use other languages within R. You can use Python within R. You can use other programming languages like C and C++ and Fortran. You can do all those sort of lower level programming languages within R. And that's what a lot of times packages are built off of. So the ecosystem that's developed has thousands of packages that represent the cutting edge in data analysis, statistics, and data science. It has a very supportive community of users. This is something that is often a big challenge with the other statistical software packages out there is when you have a question, who do you ask? Sometimes if you pay for software, you can ask for help from the people that make it. But the user communities that often exist in other statistical software packages are often limited or not very nice. Trying to ask a room full of economists how to do linear regression is not a very nice thing to do. It's not very helpful. The R community, though, is composed of a lot of people like you, people that are learning this, people that are learning new things every day, and they want to support people that are like them. And that's, you know, I've helped a lot of people learn R over the past 15 years, and you know, it's a really rewarding experience. I love doing stuff like this, and every time I try to sit down and teach people how to do something, I learn something new in R. So, let's see, yeah. So the open source nature of R tends to lend itself to collaboration, the sharing of ideas, and sharing of resources. There's somebody on the call tonight, a professor from LSU, who I saw something about this on Twitter the other night and decided to come along for the ride. So welcome, Samuel. You know, this is the sort of thing that I love to do, and I'm glad to have people like you on board. So the first thing we're going to do is we're going to talk about installing the software, which is, again, if you know how to install software, this is an easy lift for you. If you've never installed software before, get ready to go. There are basically three things that we're going to do, and we need to do them in a particular order. How many Mac users do we have tonight? 1, 2, 3, 4, 5. 5 Mac users. Asia is a Mac user too, I think. There's a little bit of a different method to install things for Windows versus Mac, and certainly for Linux. We could have a special conversation all about that. So the fundamental thing we have to do is we have to install the base R system. This is a basic user interface and the core set of libraries that R is composed of. So that's the first thing we're going to do. If you already have a version of R installed on your computer and it's not the current one, I would recommend you remove that first and then install this. Alex, you have a question? Okay, I guess your hand's raised. You don't need, okay. So the first thing we're going to do is we're going to install base R. And I've got links here to all these things. The place where you go get R distributions is called CRAN. It's the Comprehensive R Archive Network. It's basically the group of users that, here I'll put the link from the notes, link takes you directly there. This is where you go and download the main installers for R, depending on what type of system you have. If it's Mac, you download this package installer here. Once it downloads, you click on it in your downloads folder, and it will ask you a series of yes or no questions to install the program on your computer. That's all you have to do in that step. Same thing for Windows. Windows is very similar. If you want to install the base package for R, this is the core set of libraries, and it says right here on the website, this is what you want to install for the first time if you're installing R. Click on that. And again, it takes you to a very clear download link. You click on the download link. It'll download the software to your computer. Once it finishes, here, click on it. And why is it going? Come on, R. Come on, website. Why isn't it going? Classic. Seriously. Maybe it's just that one. Maybe it's because I'm sharing the screen. Of course, it's because I'm presenting to a group of 20 people. That's why. So it should, when you click on it, download. Okay, there it goes. Okay. So it asks you where you want to save it. There's the executable file. So we'll save it to the download folder. It's not too big. Once it finishes downloading, you'll click on it. Oh, okay. I ask you for, okay, the first thing I see when I do it on Windows is the language. R is ported to lots of different languages. We'll use English. Brings up an installer. And it's going to ask you a series of questions. It gives you this license information. R is a publicly distributed piece of software, but you can read the legalese if you want to. It'll ask where you want to install it. If you don't want to install it at the default location, you can choose where you want to install it. I'd recommend not changing. I recommend not changing the defaults on any of the install things, because R is going to think it's installed in a given location. If it's not installed there, you could run into problems further down the line. It already exists. I'm running R right now, so I don't want to overwrite my current thing. So I'm going to say no here. But you would follow the next steps until the software is finished. It's pretty quick. It takes about maybe 30 seconds to install. It's a very quick process. So that's the first thing you're going to do, is install the core set of R software on your computer. The next thing you're going to do once that's done is you're going to download and install Rstudio. Rstudio is a piece of software that started being developed in the mid 2000s. I think the first time I ever used it was probably around 2009. I went through various iterations of other software to use R in the past. Emacs is one. There were a bunch of really bad user interfaces to R that existed earlier in its history that have kind of gone the way of the dodo. Rstudio is the one that's really persisted, and it's become a corporation. They'll sell you a professional use version of it for $1,000, and they'll provide full tech support for it. But for the base user like you and I, the version we're gonna be downloading the desktop version, which is 100% free. Same process, whether you're on Mac or Windows. Again, you can click on the download link. I know what it's doing now is it's asking me to save the file. Same process as before. Click on the executable. And it will ask you to be the administrator, and that's fine. If you do not have administrative privileges on your computer, this is going to be a problem. So for those of you who are GRAs in the department, Rstudio should be on the GRA computers already. If it is not, please let me know and I can install it for you on those. Okay, so Rstudio is currently running, so we'll close it. So it doesn't like to do it when it's running, so we'll open it again. Same process as before. It's going to have a nice little welcome screen. Walk through the various, it's gonna want to install itself to your program files. You can change the name of it if you want to. I wouldn't do that. It's going to create shortcuts and things for you, so you can see it on the desktop and see it in your programs folder and things like that. It installs a bunch of things that it needs to run. It has a bunch of other software that comes with it that's very useful for building types of documents. There's a piece of software called Pandoc, which just came up, which is used to make PDF files. There are other things like the Sumatra PDF client for viewing PDF files. So it comes with a little bit of other software bits that are useful here and there when you're doing various types of things in Rstudio. And it takes a second to finish, and here it goes. Okay, so it's finished now, and it'll live in your program files. Let me do one more thing first. If you're a Windows user, and you plan to be installing a bunch of packages, I would recommend, it's not really required, but I'd recommend that you download this other piece of software called RTools. RTools, you don't have to do this on Mac. Mac already has a bunch of the programming, they're called compilers. They're pieces of software that run like Fortran and C++ code and Python code that already exist on Mac because Mac runs Linux. Mac's a version of Linux. Windows doesn't have these tools by default though. And so you need to install these things. And that's what RTools is. RTools is a suite of software that gives you the compilers that you need to build source code packages. You may not need to do that ever. You may need to do that the first day you use R. It kind of depends on what kind of things you want to install. So that's optional. It's a piece of software just like the other ones. You download it, you run the executable, you follow the queues. I would accept the defaults, and it'll take it a second to run, and then it'll be installed on your computer. You won't interact much with it. It's going to be there when you need it, and you'll be grateful for it. But you usually won't interact with it very often. It'll be called upon when needed. So are there any questions at this point? Are people live installing this as we're going? Anything in the chat that I need to know of?
There have been a few questions in the chat, but we've answered them.
Okay, very good. Thank you very much, Scott. Okay. Okay. So the next thing we're going to talk about is using this Rstudio program. This is going to form this is how you're fundamentally going to interact with R on a daily basis. There is, if you go and look in your software list, you'll see this thing here, R and the version number. This is the traditional R graphical user interface. It's terribly frightening because there's nothing there. there's very little in the base R user interface. And that's why the people, ever since R is invented, people have been trying to write a better interface to use it, because R is a wonderful tool. It just doesn't look very attractive. And it sent many a first-year graduate student screaming because they see this and they don't know what to do. So we're not going to touch this thing because it's just terribly underdone. Instead, we're going to load Rstudio because it's just a much better way to use the software. So it's this nice baby blue button, and it's going to load. Nice, fresh Rstudio version. And yours might look a little different than mine. That's okay, because I've tried to make mine look as default as possible. The windows might be in different locations a little bit, but I've done mine in a particular manner to focus on a couple of the windows and give them primacy versus to not spending as much time on the others, because there's a lot of stuff here that can get in your way. So what we're going to do is we're going to go through these windows and look at what each of them do. So Rstudio is what's called an integrated development environment. And integrated development environments exist for every programming language out there. They're basically a way so you can write your code in one part of it, you can see what the code's doing in another part of it, and you can interact with other programs or things like that in other parts of the development environment. And this is fundamentally different from the interface I just showed you, the basic graphical user interface, because it gives you a lot more tools to play with, a lot more functionality. It has 4 basic components to it that we're going to look at. And I've tried to organize my version of Rstudio running here in the same way. Oops. You've got your code window. This is where you're going to write your code. You can write code in R. You can write code in a language called Markdown, which is how I created all these notes here. I can give you my Markdown file that I use to make all these notes. You can write code in Python. You can write code in SQL. You can write code in C++. You can write code in lots of different languages within Rstudio. We're not going to be doing that tonight. We're focusing just on R. So when you first start it, you may not see that, but if you go to this little plus new file button, it'll show you the different types of files that you can open. And the fundamental type of R file that we're going to be working with first is called an R script. And this is just it's a text file. It's just like if I go down here to Notepad or WordPad, I use a slightly fancier version of Notepad called Notepad++. It's just a text file. It's nothing fancy. It's just characters and numbers and letters, no formatting, really, really basic stuff. This is where you're going to start writing code. And as you get more into using R, you're going to write different types of files. And tomorrow we're going to spend some time talking about different types of files that are associated with R. Right now, we're just going to be looking at this one, and we're actually not even going to be writing much code tonight. Okay, we're just taking the tour right now. The second part that we're going to be, so the code window, it's also called the source editor pane. Okay, that's like the Rstudio that they like to call it. It's this window here. This is where you will write your R code. And so you can write in several types of files. Basic one is called an R script with a file extension .r. Okay? This is like the fundamental R program file. Okay? The code window is where it allows you to write and execute code one line at a time, or to run an entire script. I typically will use this when I'm first doing something. When I'm first trying something out, I want to test and see if it works. I think Sam and Sarah have seen me do this a lot when I work with them the past year. I'll start out with one of these. Once I get things going a little bit, I'll change it to a different file type. But this is where I can fundamentally start doing things in R, writing code to do things. I'm just going to make a quick object. I'm going to call a variable X, and it's going to be random normal deviates. If you don't know what that is, don't worry about that yet. That's why you're taking statistics. I'm going to make 100 of them. Okay. This is just 100 random numbers from a normal distribution, like the bell curve, right? So this is I'm going to make this, and I've written this line of code. And if I want to run it, I can put my cursor right there, and I can hit Control and Enter, and R ran the code. And you can see on this other window over here, this is called the console. This is where R ran. It took the piece of code that I wrote and it interpreted it. Okay, so it took it, it did what it said, and it showed you over here. I didn't tell it to do anything else with it. I can say print X and run that, and I'll see there is a bunch of random normal deviates. Okay, so they're all there. Check. That's pretty boring. But this is starting out very, very basic. Okay. Okay. So if I have a bunch of lines of code that I want to run, I can highlight them and do the same thing. Control Enter. It'll run them all and do whatever they tell the computer to do and display it in the console. So oftentimes this is, you don't have to go and highlight the whole line. You can just put your cursor on a line, hit Control Enter, and R will execute that line. Unless you ask R for output, it typically won't give you output. And the more and more complicated stuff you get with R, you'll start doing a lot more things in it very, very soon. Again, this is just a fundamental tour. The next part of the software is called the console. This is this part of the software over here. Every time you start Rstudio, you'll see this information here. It'll tell you the version of the software. It'll tell you what platform it's executing on, give you license information, things like that. This is where any sort of non-graphical output that you request from R will be displayed. So again, I had a bunch of numbers over here. It did exactly what I told it to do. It printed the numbers. It returned the thing that I told it to do. It just printed it here. Just prints the output to the screen. This is where all non-graphical output will be shown. Any numeric output that you want will be shown here first. In case you have an error, so I'm going to make something real quick, and I'm going to make something go wrong. Okay, so I'm going to make X be X and then NA. NA is R's missing value code. Okay, and we'll talk about this more later. But what I'm basically doing here is I'm taking these 100 random normal numbers, and I'm going to add a missing value to the end of it. Okay, I'm doing this for a reason, because then I want to go in and I want to take the mean of X. Okay, the mean is just the arithmetic average. If you sum up all the values and divide by, in this case, 101, you will get the average of the variable. So if I try to run that, the reason I'm doing this is because if you do something and it's wrong, this is where R is going to show you the error. Okay. So, grab it. Oh, wait, do that. Okay. There we go. It didn't give me an error this time. Let's go in here and do this. Okay. So what I did is I forced an error because I didn't put a comma there. and R gave me this red error file over, this red error warning over here. It's an error message. Unexpected numeric constant in this argument here. This is, if you see, this is where errors will pop up, okay? Errors and warnings, this is where they will appear. This is kind of a dumb one here, but again, this is just fundamentals right now. Error messages, warnings, this is where they'll appear. A common one that I do is there's a function called length, GTH in R, that will tell you how long a vector of numbers is. So how many elements are in an object. So the right way to do it is to type length and X, and sure enough, it prints out 101 because I had 100 random normals and I added NA to it. So it's 101 length. But what Sparks does a lot is I do LENGHT. I don't know why I do that. It's just something that I do all the time. It's kind of funny, like on Twitter, people will say, like, I've defined a new function in R called this just to get around me stepping on my toes, misspelling it. But if I run this, I get an error. And R tells me there isn't a function called linked, right? Because I'm silly and I misspelled the function name, okay? So this is where R is going to tell you where your errors are occurring. And you're going to see the errors as soon as the code runs. Okay, R's output is typically plain text, although we can produce much prettier output using different output methods later. Again, all of these notes here, all the output in these notes come from R code. Okay, so in this case, it's a very nice formatted document, but I wrote it using R. Okay, a bunch of plain text looking code. I can also type commands or code directly into the console. So if I go in here and I type mean of X, okay, so I type the function that I want, it's immediately interpreted, length of X. So a lot of times when I'm trying out something for the first time or I'm testing something to see if it works, I'll do this. I'll do just type directly into the console until I used to do this a lot more if I wasn't sure something was going to work. I would type it in the console directly, or immediately interprets it and gives me what I want. It helps me sort of troubleshoot things. Once I'm happy with it, then I'll save it in my code file so I don't have to keep typing it over and over and over again. That's why you write code. So the things that you're doing a lot, you don't have to write them over and over and over again. You could run the code again and completely repeat the analysis that you were doing. That's something that Rogelio and I have been working on this project in Asia as well, on this unemployment project for a while now. And I started writing code for this last summer. And the code that I wrote last summer to make figures and do analysis, I opened it up this morning and we met for a while. I reran it and it produced the entire analysis from last year's paper, just like that. Okay, I couldn't do that if I was clicking buttons. You cannot do that in a non-coding environment. Okay. So that's one reason why we write code, to make things reproducible. So console pane is where you're going to see most of your numeric output from any sort of thing that you ask R to do. The next part of this is called the environment or the workspace browser pane. And on my RStudio, it's down here in the bottom left corner. This is called the environment pane. And these are resizable. You can make them smaller or larger. You can make them, there's a vertical delimiter, so you can take up different amounts of real estate in the RStudio window. The environment is where you're going to see anything that you create in R. And for example, you see this variable X that I made here, this object called X that I made here. And you can see its values, its name is X, and it's numeric, means it's full of numbers, and its length is 1 to 101. And it gives you the first few values of it. Okay, depending on the type of objects that you're working with in R, like if I read in an Excel spreadsheet, it'll appear in my environment here. I'll show you how to do that in just a second. But this is where anything that you make when you're writing code will appear. R is called an object-oriented programming language, meaning that whenever you do something like this, I take something and assign it to a variable. I can do that here. I do a different one. I'll call it cat is 1, dog is 55. Whenever I run these pieces of code, all of a sudden these values are stored in my environment. Okay, I can use them then. Cat divided by dog. And it gives me the output of, because those are variables, right? So, and I didn't store that as an object. I could though. Okay, and every time I store something, every time I assign something on the right-hand side of an equal sign to something on the left, it's going to store it as an object. And so the environment is really there to show you everything that you've created. This is going to be really cool later because we can view data sets here in a minute. Yeah, depending on the type of object something is, you may be able to click on it and see more about it. There's also a very useful tab here called History. And this shows you stuff that you've typed before. I do this a lot. I'll do something right, and then I'll screw it up. And so, but if I did it right once, it's going to be in my history file. So I can go over down here and I can right click on, I can do this. I can highlight the line of code that I want, and I can say, okay, to console. And it will send that line of code directly over here to my console where I can run it again and be like, oh, well, you know, that piece of code worked. I can save it again. If I want to, I can put it to my source window. Oops. Do that here. I can do, if I do to source, it'll put it in the code file like that. Okay. So the history can be very valuable sometimes if you're looking for something that you've done in the past. There are other things here. The connections window. This is if you're connecting to databases. We won't be doing that in this session. Git is a version control system. I'll do another presentation about that soon. It's really useful when you're collaborating with multiple people. And tutorials, these are things you can look at that are tutorials to various packages, kind of shows you how to use it. Okay, last but not least is this last part of the Rstudio window over here, the files and what I say the output pane. So the files and output pane, this is where you can interact with your operating system. This is where you can click on files that already exist on your computer, open them up in R or in something else. Like so example, this is a folder of common things that I use on courses that I teach about R. There's a bunch of different stuff here. Here's a PDF file. If I click on the PDF file, it'll open the PDF file in my PDF viewer. So that's nice. Here is an R code file. I click on it. It will open the code file directly into R. So it's a good way to interact with the system. Let's see something else. Here's an R data file. This is one way in which R stores data. It already lives on my computer. If I click on it, it'll ask me, do you want to load this file into your Rstudio R session? Yes, I do. And then I have, it generates the code that it used to read the file in. And then you see in my environment down here, I now have this new thing under data called PRB. This is this world population data sheet that I was talking about earlier. So this is a very easy way for me to click on existing files that are already on my computer and have R open them. Let's do that with something else. Here's a version of PRB that's a comma separated value file. So this is like a text version of an Excel spreadsheet. We can click on that and I can either view it or I can import it. Let's say I want to import it. Click on import. It'll read the data in. What do you want? You know, you have a few things here. There are specifications of how you want to read the data in. What do you want to call it? By default, it's going to call it the file name. It can, if it has things that are separating the values from each other, this time it's a comma, it knows that. And then it generates the code for you right here. So that's nice. It shows you the code that R is going to use to read the data from the computer. So we can hit import, and it's going to read it in and open it up for us. And sure enough, we have our data sheet here called PRB 2008 all. You can also see it in the environment down here, and you can browse it, or you can browse around it, check it out, things like that. Okay, so this files tab down here is really useful for interacting with other files that already exist on the computer. There are other things here as well. The plots tab. This is where any graphical output that you make in R will appear first. So we're going to go over here, and I'm going to make X again. So here's X is our normal random variables. And this time I'm going to do a histogram of X. Histogram is just a relative frequency plot showing the relative frequency of the values of a variable. We're going to run that, and sure enough, it shows up down here in the plot window, showing you the distribution of the various values of X. Okay. This is once the plot is here, you can zoom in on it to open it up in a little plot viewer. You can also export it as an image or a PDF. You can copy it to a clipboard. You can use it to paste it into Microsoft Word or something like that if you want. Things like that. There are these other tabs here as well. The packages tab. This shows you all of the packages that are currently installed. So these are all the different user contributed packages that R currently has access to. You can search those. Like here's one of my favorites. You can click, it's all HTML, so you can click on it and it'll bring up the documentation page for that package, so you can see all the functions. You can search for things. So if you're looking for a function to do something, you can give it a keyword. It'll show you all the help files that match that. There's a viewer pane that is very similar to the plot pane. Sometimes output will appear here. The most graphical output will automatically go to the plot pane. Okay, so where are we at on time? Sorry. How are we doing in the chat? We need to do any questions in the chat that we need to answer right now?
I think we've cleared them all up.
Okay.
Yep.
Okay, so let's see. So right now we have a break at 7, so we're about 10 minutes ahead of schedule. If anybody has any questions right now about the basic Rstudio window, I'm happy to talk about that. Or if there's something that you see that I didn't talk about, ask away, and then we'll take a quick break. So are there any questions about the Rstudio window that we didn't talk about?
Was everybody able to successfully download both programs?
Thank you, Jules. Has anybody had any problems installing the programs or opening them? Don't hear any screaming, don't see any fires burning, so everybody must be on task.
No crying yet.
No crying yet, not yet, well, yet. Have you seen Walking Dead yet? No, but I want to eventually. Okay, there's a lot of stuff in Rstudio. There's all these tabs up here that I didn't talk about at all. I don't like the basic Rstudio. So one other thing that I like to do is I like to customize it. So if you go to the Tools tab and you go to Global Options, this is where you can set a lot of the fundamental settings of R. A couple of the ones that I always have people do, because it drives me nuts, are if you go to Tools and Global Options and you click on the Code tab, there is a there's this one option here, soft wrap R source files. What does that mean? That's going to make, if you write like a really long line of R code, it's going to just keep going and going and going and going in the code window. That drives me nuts. If you check this box like this, like mine, it'll wrap it. So it's like it'll do a hard return, and it'll just continue the line easier. So it's easier to read. So I recommend people do that. I recommend people go to the general tab, and whenever you close R is going to ask you, do you want to save everything that's in your environment to like a data file on your computer? I recommend never ever to do that, because then you have this huge file sitting around on your computer with a bunch of random stuff in it that you probably don't want every time you start up Rstudio. So there's a thing here in workspace, save workspace to R data on exit. Mine is on never. Okay, I don't like that. I don't want it to ever save my workspace. I don't want it to ask me. You can do always. Don't do that. Don't do always. It'll mess up your life later. You can have it ask. So it'll ask you, do you want to save this? But I recommend don't do it. It's not worth your time. Just hit never if you don't want to do that. One other thing that I do is I change the appearance. Like, this is kind of vanilla looking right now. This Rstudio, it's all I don't know. It could be anything. It's just very whitewashed. So there's a lot of different themes that exist that change the fundamental way Rstudio looks. You know, if like it's like on your phone, if you don't like the white version of things, put on the dark theme, and everything will be sort of dark and gray and things like that. Same thing here. There's lots of different color versions that you can turn on to make Rstudio look however you want it to. I'm typically a cobalt person. I like the blue. I don't know. Blue is my favorite color. So that's fine. I can make the font size bigger. Like for the presentation, I make the font bigger. As I get older and older, my glasses get worse and worse. So I've been noticing my font size creeping up naturally. You can make it zoom in to make it appear bigger. Again, if you're teaching things, there are other themes you can turn on. But this is where you can kind of customize Rstudio to look the way you want it to. Okay, so I'll apply that. And then I like this better. This is the way. This is how my Rstudio looks when I'm teaching normally. So I'm just going to leave it like this because this is the way I like it. Okay, so what we're going to do right now is we're going to take a quick break. We're going to take a break for 10 minutes. And so at 7:10, we're going to come back on, and we'll start looking at the next. Is that what we're going to be doing next? There's Rstudio. Yeah, the next thing we'll come back after the break. We'll look at reading common file types into R. So this is reading common data files from different software packages. Okay, so we'll see you back here in about 10 minutes. All right, thanks.
Assigning operator. So I read that I use the different one always.
I know, me too.
like this equal, you cannot use, it doesn't allow at some point, right? Like better, preferable is the other one, or are they the same?
So Asia is asking a very good question. And she's noticed something that's very, very different from what I normally do. So she's asking the question specifically about this thing right here, this innocent looking little equal sign. When I grew up, when I was learning R, growing up on the mean streets of Knoxville, we learned how to do R like this, where we have an arrow operator. Anything that's on the right-hand side of the arrow operator gets stored in this object. And that's what she's talking about.
So are you sharing screen?
Say, oh, I'm sorry. Yes, sorry. Yes, thank you. Okay, we are recording again. So I did do that. So thank you, Jules. So Aisha is talking about this thing right here. So all throughout tonight, I've been using this equal operator, right? So something on the right-hand side of the equal operator will be stored in the thing on the left-hand side of the equal operator, okay? This is how you create an object in R. This is one way you create an object in R. When I was growing up on the mean streets of Knoxville, Tennessee, learning R, when there weren't any books for it, we used this thing, which was the arrow operator, right? It is not less than -1. It is an arrow, it's basically like archery, right? This thing here on the right-hand side of the arrow will be shot into this thing on the left-hand side of the arrow and stored there. These two things are equivalent. It really is a generational thing. Like if you're an old crusty dude like me, then this is the way you write all your code, is with an arrow. But I've been working all summer with this group of data scientists from all over the country, and they're all younger than I am, and they all do things like that. And they're very passionate about it. They're like, well, why don't you use the equal sign? Because I'm old and crusty. I don't like to use the equal sign. I like the arrow. That's just the way I learned how to do it. So to answer your question in a very long and roundabout way, it doesn't matter. Whatever's on the right-hand side of this ends up in here. Whatever's on the right-hand side of this ends up in the exact same place. They're equivalent, okay? It really is a stylistic thing. If you're coming to R from other programming languages, this is typically the more comfortable way to do things, okay? Like Python, this is how assignment works in Python. This is how Python or assignment works in Fortran. This is fun. This is how a lot of people do programming works. This is an R thing.
Okay. I always saw this.
I know. I felt really bad not doing that. I've been really struggling not to use the arrow, but you're absolutely right. Yeah. Thank you for noticing that. You're paying attention. It's wonderful. Thank you. Yeah, all the code I ever teach with, you will only ever see me do this because it's old crusty dude habit. Okay, other questions? I saw some great comments in the chat. If we're need to get help software working, I'm happy to, or one of my minions can help you get that going. Minions, I say that with all due respect and admiration, you know that. Okay, so the next thing we're going to be talking about is reading common file types into R. So you all probably have done this before, either at work or at school. You've had a data file. Your previous advisor made you use SPSS or Stata or something like that, and you've got this stuff laying around, and now you want to use R to analyze the data. This is one of the best exercises you could possibly do to learn R. If you've done something 100 times in Stata or SAS, go and do the same thing using R is the best way to learn how to take your workflow from the previous existence and translate it into the R environment. And you don't have to go and recreate all these data files from scratch. You can use the stuff that you already have, no matter what software it was written in. R will read statistical software packages, SPSS, Stata, SAS, Excel, Minitab, DBase. It'll read most, if not all. I've never encountered a data file that R couldn't read. This is a relatively new phenomenon. There have been packages that are for a long time. This has been a relatively new thing that they've had this sort of explosion of package reading softwares. But R, I'm pretty happy with how R is doing this now. And so if I have something that exists from a previous analysis, R will read it. So there's a few different ways to go about doing this. I think probably one of the most common things that people probably have laying around are spreadsheets, either Excel or some sort of open document spreadsheet type, or the text version, text equivalent of an Excel spreadsheet, comma separated value file. these are sort of ubiquitous data file storages that I would more than happily burn and get rid of and never ever look back. Excel is not a data management piece of software. It is not a data analysis software. It is a way to screw up your data faster than you can say spit. I have screwed up many data sets using Excel that were completely irreparable, and I will never ever go back to using Excel to do any sort of data analysis, manipulation, or storage. It's the devil. Don't do it. But I know that, that's the thing. You work in an organization, and people are constantly sending you Excel files with this or that in it. So you've got a lot of these things laying around. How do we get these things into R? So the easiest way to do this is to use our file browser. Okay, this is the dead easiest way. If you are scared to death of writing code, you don't want to write code, but you want to get your data from point A to point B into R, this is what the easiest way to go about doing it. Okay, so I'm going to make my file browser a little bit bigger, and we're going to go hunting for an Excel spreadsheet. Here's one that's here's a comma separated value file, very, very similar. We're going to use it to start off with. We saw this earlier. All I got to do in the file menu, in the file window, is click on a file, and I can either view it or import it, right? So I'm going to import it because I want to bring it in. And we saw this before. It's going to give you a preview of what the data look like. What do you want to name it? This is a terrible, terrible, awful name for a data set. I'm going to call it dog, or let's call it PRB. Let's call it PRB. We're calling it PRB2. Everything else looks okay. If I wanted to, write code to read it in, then this would do it. Okay. So I'm going to hit import, and that'll bring the data in and automatically let me browse it and take a look at it. Right? So I can see all the columns. I can scroll down all the rows, see all the variables. This is fantastic. I can sort it. Click on this so I can sort. So these are all the African countries. I can sort it alphabetically by the name of the country. I can sort it numerically by population size of millions. So this is kind of neat. It looks like a spreadsheet. I feel kind of like I'm back home in Excel. Let's go find another one. I might have to go search a little bit more to find one of these. I shouldn't be doing this kind of thing on the fly because it's dangerous. Let's find one. Let's go over here. Where's my OneDrive? There's that. There's got to be an Excel file in here somewhere. Yeah, there's one. Here's one. I don't know what this is. It's some sort of analysis that I did somewhere. Import it. You can see. Okay, there's a function that lives in the package read Excel. The function is called read Excel. It reads. It's going to read it in. It gives you a preview of it. Import. Again, easy peasy way to get that Excel spreadsheet that I had done before into R. Okay, no problem. So we're going to go back. Go back over here to GitHub. You can pretty much do this with most file types. We're going to go back over here to my GitHub thing and data. This file format here is an R data file. So R, if you click on it, R doesn't have to worry about loading it in. It'll load it in the environment, no problem. Let's see, where is something else? DTA. A DTA is a Stata data file. This is it's still the Population Reference Bureau data set. I'll click on it. I can import it. So again, there's a function called read DTA in the Haven library. Here's the code that's going to actually do the working for you. Read it in, open it up so you can browse it, so you can read your Stata files in. This works with SPSS, works with Stata, Excel, comma separated value file, very common format files that you have from previous experiences. That it's a lot of you have probably done some sort of analysis before in some other software, and so it's an easy way to take your data and bring it in R. SAS files. SAS files, for some reason, it won't do that automatically with SAS files. But there is a function called read SAS, read underscore SAS in the Haven library to read a SAS data set directly in. So I can show you how that works. Go down here, starting line. We're going to call this dat, and I'm going to use the arrow this time. Okay, it works the same way. It's the same thing. Okay, so we're going to use this Haven read SAS file, and then you tell it where the file is. So this file I'm going to read in is that's a neat little trick. Okay, let me show you that. I went fast. So Rstudio will tab complete names of things or directory names if you give it something to start with. So I'm going to give it a this is how you, I want it to look in the OneDrive folder on my computer. I get the first 3 letters of it, then I hit tab. And it gives me options. These are 2 folders that live on my computer that both start with 1. I want that one. The next one I want to do is it starts with projects. Okay, so I can either open one of these 2 files. I don't want to do that. I want to get in this folder. I'm going to go in this one. This is one I was working on with Rogelio this morning. Let's see, where is that SAS data set? There's my SAS data set that I downloaded this morning. And I hit Control Enter. It's a big data set. It's going to read it in. This is the 2010 and 2011 current population survey monthly samples from January of last year to June of this year. It's still going. It's a big data file. Sometimes it takes a second. It is millions of lines, so just be patient. When it finishes reading, I'll have this object called dat right here, and it'll tell me the number of rows and the number of variables that are in it. Okay, so there it is. Dat has 1,927,000 and change people. So these are individual survey respondents, and there are 63 variables in the data set. Okay, so this is a big national survey that a lot of people use for economic analysis. Okay, so I read it in out of the SAS file perfectly well. You can also read data directly from the web. A lot of times, and this works a lot. This will happen a lot when you're working with an organization and they repeatedly publish a data file, say monthly or yearly, and you know you can either go and download a web link of a data file, or you can go read it directly from the web. An example of this is, I'm going to go to my GitHub site, and I'll talk about GitHub in a future session like this. This is a way to, it's a place where you can share and collaborate on projects, computer science or data science type of projects. I have a repository here, like a little area where I put stuff called data. Okay, and this is where I store a lot of data sets that I use in my classes or in courses I teach, things like that. And I've got a bunch of different data sets here. And this is actually the same place I'm browsing on the file tab over here. It's the same information. This one's just stored on somebody else's computer, and this one's stored on my computer. Okay. So here's a data file right here. It's a CSV file. Okay. It actually shows me a preview of it here. If I want the actual data, I can click on this raw thing here, and it will show me the raw text data. Okay, this is really ugly, but right here is the web link to where this data lives. Okay, so I can copy that web link and read it directly into R. So we'll do PRB. Let's call it 3 is sign it read. I'll do that one. That's fine. So we're going to read CSV as the function we're going to use, and we're going to give it a URL. URL is a web address. Okay. And this is in the notes. Same thing, we're doing the same right here. And I'm going to give it that web address and control enter. And it reads it directly from the web into R. And that is really cool because you can share information really easily like that. If you're working with somebody else, you say, okay, we're going to use the March data from so-and-so. Here's the web link to it. They can immediately go read it into their computer without you having to send it to them. You know, I haven't sent anybody, emailed somebody a data file in years because I can give them a web link to it. I can store it somewhere in the cloud, give somebody a web link to it. They can read it directly to their computer. Easy peasy. Okay. Sending files by email is, don't do that. It's a way to clog up everybody's inbox. Okay. This is a super easy way to read files that live on the web somewhere directly into R. That, you know, this sort of functionality, it exists in other softwares, but it's not nearly as easy to use. So this is a neat way that R can do that. Okay, so this URL function is really handy. You can read other formats of data, like if you have a Stata file that lives somewhere on the web and you want to read it in, that, you know, you can do that. A SAS data set, any sort of format data set works in the same sort of principle. If you give it the web link to it, and then you say, okay, I'm going to use this reading function to read this website or this web address, it'll read the data from the web directly, which makes everything more repeatable and easier to share results and things. Okay, so I think the last topic for tonight is, that's not the right one, is going to be basic summarizing data. Okay, so we worked so far, we've looked at Rstudio, we've read some data in from our computer, so we have data in our environment. What are we going to do with it? So one of the key and initial first phases of doing any sort of data analysis is descriptive analysis, right? This is where you're basically doing some sort of statistical or graphical summary of a variable or multiple variables to kind of get an idea of what the data look like. Okay, I do this every single day. Whenever I load a data set into R, I want to make sure, like, what are the values? Are there weird values in there? A lot of data you get, especially survey data, they'll give weird values for missing values, for instance. So, like, let's say you have a survey question and it's like, did you have a good day? Yes, no, or refused. Okay, so those are the three possible answers. So yes is a 1, no is a 0, and refuse is a -9. Okay, if I do a just basic numeric summary of my variable, I'll see the 0, the 1, and the -9. And I'll know that that -9 is not a real value. Okay, this involves working with sort of the people that the documentation for the data that you're using, called the code book for the data that you're using. But also it's your job as the analyst to look at the data. Okay, whenever, you know, I always use the kind of the funny joke, you know, I don't like to get my data from somebody in a dark alley, right? I like to have good documentation of where my data come from. This is called like metadata, right? It's information about data. Do not get data from strangers in trench coats and dark alleys. You can't trust them, okay? Plus, you have no idea what the values correspond to. It could just be a bunch of 1s, 2s, and 3s. You have no idea what this stuff is. Always use documentation for data. Always use vetted data sources. In the second stats class, we will go through a lot of that in terms of using raw survey data and analyzing it in R. But this is sort of a good first step to doing that. Basic fundamental descriptive analysis of data is one of the most overlooked and underappreciated tasks out there, and it will absolutely save your bacon when it comes time to actually using stuff in dissertations and research projects. Okay? So we're going to illustrate a few simple but effective commands for summarizing data in R. The fundamental way in which R stores data is called a data frame. And this is like a spreadsheet version of like a two-dimensional array of data. The rows are observations, the columns are variables. You can think of it like an Excel spreadsheet, right? This is sort of the very, we're comfortable with this picture of what data look like. That's it looks like a table, like a spreadsheet, things like that. But R calls these things data frames. Okay, so you'll hear people throwing that name around, and when they're doing that, they're talking about a two-dimensional data structure with observations and rows and variables and columns. Okay. These things can store lots of different types of data. So we're just gonna take a look at this one that we read in, this PRB data, and you can see. Let's look at this one. So the first three variables here contain text information, right? So these are characters, right? They're names of something, they're words. I've been working this past week with some people that do natural language processing, okay? And they'll have a single variable that's like 10,000 words. So within a single field in a spreadsheet will be a 10,000 word document, okay? And it's like, it's an entire corpus of some sort of text document, okay? And that's their data, okay? This is a much cleaner version of that. It's only a single string, a single character thing. So Europe, Western Europe, it's a single, very short character value. There are numeric values. So country, region, continent, these are all characters. POP 2018, CBR, CDR, these are all numeric. Okay, so you can store multiple times of data in a data frame. That's what I'm trying to get at. There's a few different ways to access a variable within a data frame. The customary method in R is to use the $ operator. So let's take a look at that. So if I want to look at this crude birth rate, this is the number of births in a given year divided by the population size. If I want to look at the values of it, I'll do PRB2, and then to look at the actual variable, I'll do $. And you see automatically what Rstudio did when after I hit $, is it showed me all the variables in the data set. So this is one of the fundamental ways in which you access a variable in a data frame in R, is with this $ operator. So I have my $ there. I can type CDCBR, and it'll actually just print all the values of that variable to the string. Okay, so this isn't terribly informative. I can stare at these numbers till the cows come home, and I won't be any smarter. Okay, I can kind of get an idea what the high value and low value are, but it's just raw data. Okay, what my job is to kind of summarize that. Okay, so one of the most fundamental and easiest and most useful functions in all of R is the summary function. So I will type summary, and I'll type my PRB2, my $, and I'll even scroll down here to this variable. I don't even have to type code a lot of times, so I can automatically just browse. Now, if I type summary of this, I'm going to get what's called a 5-number summary, which is an invention by the statistician called John Tukey. That will be on the test. There's no test. John Tukey was this sort of statistician who was very prominent in the 70s and 80s, who was a big proponent of exploratory data analysis. And you'll hear me talk a lot about exploratory data analysis as we get to know each other. But this is going to give me a basic numeric summary of this variable. So I hit enter, and what do I get? I get the minimum. So this is the lowest crude birth rate in the world. I get something called the first quartile. So this is the value of the variable that 25% of observations are less than. Okay. And again, in the stats class, you'll learn about quantiles and quartiles and means and medians and all this good stuff. This is going to give you a lot of that summary information right here. The median, which is the most commonly occurring, it's the most common, it's the value which 50% of the data are less than. The mean is the arithmetic average. Third quartile is the value at which 75% of values are less than. And finally, the maximum is the highest observed value in the data set. So this gives you a lot of information. You can see the range of the variable. Does it have negative values? Is it strictly positive? Does it have zeros in it? There's a lot of information I can get from this that it's very useful. Like remember my old my example up here. Like let's do my X example. X equals our norm 100, and I'm going to add an NA to it. And let's do a summary of X. Let's do it right here. Summary X. Okay, so this is cool. So X was 100 random normal variables, and I added a missing value at the end of it. So it's 101 elements. The last one of it's missing. The minimum is minus 2.2. The maximum is 2.8. The mean and the median are a little bit higher than 0. Technically it should be 0, but that's what they call sampling error. It's fine. And NAs, the number of missing values. So this tells you how many observations in that variable are missing. Let's do a real one. Let's do a summary PRB2, and we'll do. There are some down here that have a lot of missingness to them. So this is the percentage of males in the country, adult males that are HIV positive. This is a really tough thing to estimate because a lot of places don't do systematic HIV data monitoring. So we're going to do a summary of it and see what it looks like. So minimum is 0.1%, maximum is 19%, 74 observations are missing. Okay, so this is a variable that has a lot of missingness to it. A lot of countries do not have an estimate for this. Okay. So, I know there are, let's see how many, 210 observations in the data. Roughly about a third of those are missing their information for the HIV prevalence. Okay. This is a very useful tool for putting a single variable out there. You can also do it on a whole data frame. Summary PRB2. And if you feed it a whole data frame, it's going to do this summary action to every column. So let's run it. Okay. Whoa, look at all this output. Okay. So if it's a character, it's not going to give you much. Okay. So the continent, it's 210 characters long. It's a character class, meaning the type of information stored in it is text. So these first three things here aren't telling you much about these. But then for all these numeric variables, you automatically get this 5-number summary plus the mean. It also will give you missing values. So for infant mortality rate, there's 1 country missing for it. Population density, there's 7 countries missing for it, so on and so forth. So I can get the entire summary of a data set. I can go down through all of these one at a time. I can browse them. I can see, do they all look like valid values? A very useful tool. Okay, but it's not terribly satisfying. It's really ugly. It's a bunch of text printed to a screen. How am I going to use this? And if you're asking yourself that, you're absolutely right. I mean, this is great as you're I call it sort of the proofreading stage of a data analysis, right? As you're sort of, you're doing things in sort of intermediate fashion, you're browsing around. This is not something you would ever put in like a table for a paper for one of your professors, because they would look at this and be like, this is not very pretty. I want to see some pretty output. Give me some pretty output. So we're going to work to get prettier output of the stuff that you can actually use for something. Okay. So summary feature is great. Numeric. There are other packages in R that will do numeric summaries of data really nicely. And part of what we'll do tomorrow night is we'll use a particular library called dplyr in combination with a plotting package called ggplot to make some really nice looking numeric summaries and graphical summaries that are very, very functional, that look nice. A package that has a lot of useful functions in it is called Psych. It's developed by a bunch of quantitative psychologists to do a lot of fun stuff that psychologists like to do. Psychologists are a really fun group to hang around with if you like data analysis, because they do a lot of that stuff. my point is that, as you will hear me say more than one time in our time together, there's always more than one way to do everything when you're doing an analysis. There's always more than one package to do the same thing this other package does. There's 15 different ways to fit a regression model. There's 15 different ways to do a numeric summary. There's lots of options out there. Okay. So if you ever have somebody that you're talking about R with, because you all talk to everybody about R, they say, well, this is the way that my professor showed me how to do this. And he said, this is the only way to do this. That's a lie. It's a flat lie. There's always more than one way to do things in R. And just to do a simple numeric description of a data frame, here's 4 different ways to do it. Okay. So that's one of the fun but frustrating things about using R as you get more into it, is the variety of different ways to do things. So this describe function in the psych package is really fun. So if you don't have this installed, we're not talking about installing packages tonight, but let's do it real quick on the fly. This is a package that does not come installed with R. If you want to install a package that does not come with R, there's a function called install.packages. Okay. Then you have to give it the name of the package that you want. In the email that I sent you all the notes with tonight, I told you to install the tidyverse. TIDY verse. Okay. This is a bunch of stuff we'll actually be using tomorrow. But if you want to install this psych package, you give it the text name of the package that you want and hit enter. Yeah, that's fine. Sometimes it'll need to restart R to make it do what it needs to do. Then it will install the R, then it will install the package. Done. Okay. So now I have access to all of the functions within the psych package. If you want to know what those are, you can cruise right here to the packages tab, search for psych. You can click on it. Make this bigger. And these are all the functions that you can get at in this psych library or package. Lots of weird things that, like Cohen's alpha or things, or Cohen's D, correlation coefficients, correlation plots, correlation tests, all kinds of weird things. There's these basic describe by, there's all these different functions that the authors of these package included that psychologists, I guess, use sometimes when they're analyzing data. Lots of different stuff in there. So we're going to do psych. So it actually prints out a little bit more intelligible output. It's not this big 5-number summary. It prints it like a 5-number summary, but it's in rows. So now each thing is in a row. For some reason, it turned continent, country, and region into numbers, which I personally don't like. That's not legit. You can't do a statistical summary, a numeric summary of a character value that you can't. It's not real. So here's the numeric summary of this: the population 2018. This is the population in millions. It's the 4th variable in the data set. There's 210 observations of it. The mean is 36.29 million. Standard deviation 139 million. The median 7 million, so on and so forth. So you can get a lot. It has a lot of different statistical summaries here. Here's the minimum, maximum, range, skewness, kurtosis, standard error, a lot of different numeric summary values from this using that function. So here's what that sort of looks like. I think you can feed it a single variable. So you get you can feed it a data frame, or you can feed it a single variable. It will do this wide range of numeric summaries on that single variable instead of the whole data frame. So, if you're in your Stats 1 class and Dr. Huang asks you to do a descriptive analysis of a variable, bam, there you go. Homework Check. Okay. This is for the whole data frame. There's this other function called, there's a package called skimmer, which is another one of these functions that's designed to do numeric summaries of data frames. It has a function skim. Let's see what it'll do. 2. Okay, and let's see what it prints out. 3. Oh, wow, it gave me all kinds of fun stuff. Let's clear this and do that again. Okay, so it gives you a lot of stuff here. It gives you a data summary. This is kind of like in SAS, like a proc contents, the variable name, the number of rows, number of columns, the different number of different types of columns. This gives you like a text analysis of the character values. Then it gives you numeric summaries of these variables here. But if you get down, I want to make my Rstudio window a little bit bigger and reprint this. It also gives you far over at the right, like this weird text version of a histogram. So this shows you like the distribution of the values of the variable in this weird little texty format, okay? But it's a really cheap sort of, poor person's histogram if you need one on the fly, really cheap. There you go. It's not something that you can actually copy and paste out into into like a document or something. There's better ways to do that. We'll talk about tomorrow. But there's a lot of information here. One thing that I do like that this gives you is something called the complete rate. This is the proportion of non-missing values in the variable. So if you remember our HIV variable, it was really missing, right? So it only has about 65% of observations that are complete for that variable in the data set. So these different types of summary functions provide different sort of depth of the insight you can use. The basic summary function gives you a basic fundamental numeric summary, 5-number summary of a variable or data frame. These other summary functions will give you oftentimes more than you're looking for. They'll sort of vomit this information on you, like here's a bunch of output that you're probably not going to look at. This is how there's a procedure in SAS called proc univariate, which is like this for univariate statistics. It gives you like 60 different summary measures for a variable, and all you want is one. Okay. So this is how I feel about these things, is they give you a lot of information that you're probably not really interested in. So here's what that looks like. Frequency tables. So these are nice for numeric data. If your data aren't numeric, or so if you have a lot of categorical variables like a yes, no, maybe, that kind of response, or even if you want to do a frequency table of a numeric variable, something has a discrete range like 1, 2, 3, 4, you'll oftentimes do a lot of frequency tables. So good ways to do that. The basic function to do that in R is called table. So let's clear up this stuff over here. If we go up here, we can type table PRB2 continent. And this will tell me the number of observations, countries in each continent as the PRB classifies it. So the 57 countries in the data in Africa, 51 in Asia, 45 in Europe, so on and so forth. So we have a frequency table of our data here, okay? So that's what I just did there. You can do measures of central tendency. So if you know a particular statistical summary that you want, let's say you want the mean or the median, again, you'll get more of that as stats 2 or stats 1, excuse me. We can type those directly in, mean PRB 2 $ CVR, for instance, and I'll give me the numeric mean or arithmetic mean for that. Notice if I try to give it, I'll go to this variable down here, this HIV rate, HIV prevalence, and try to take the mean of it, and I'll get NA. So if the value contains missing values, NA codes, the mean function and a lot of functions will return a missing data codes. In other words, it can't take the mean of variables that have missing values. So what you have, so a lot of functions in R have options. So if we do a comma after that, and I hit tab, it will show me the options that are available in the function. Okay. So the one I'm looking for is this one, na.rm. This, a lot of R functions have this option. That basically, you're going to tell R to remove the missing values before processing it. So we're going to hit enter there. And this is asking you like a yes or no question. Do you want me to remove the values or not? In this case, I want to. So I put na.rm equals true. This will remove, this will do what's called listwise deletion of missing values. Anything that's missing, it will process those out first, then take the arithmetic mean of what's left. Then I can get the mean value for the variable and be fine with that. Okay, so there's a lot of times functions that won't operate on missing values by default. You'll have to specify this option. And this, the mean function's one. Here's that note again in the notes. The median function is also one of those. So we'll just change this to median. Okay. So yeah. Measures of variation. Common one that you use a lot is called the 5-number summary. Again, the thing I don't like about this is it just prints out numbers. This isn't terribly useful. I mean, if you know what the 5-number summary is, then you might understand it. Like if we type question mark 5num, we can go to the help file for it. And it'll tell you, okay, what does it return? A numeric vector of length 5 containing the summary information. That's useful, not really, because it doesn't tell you what the numbers are, okay? You'll see that sometimes these types of things exist in R that, you know, it'll give you what you want, but you got to kind of know what you're getting out of it sometimes, okay? Never be afraid to look up the help file, or never be afraid to ask somebody, what the devil are these 5 numbers this thing just printed out, okay? It's better to ask, that way you know. And then again, you can get the 5-number summary a different way using this, just the summary function. You'll get the minimum, first quartile, median, third quartile, and maximum. Those are your 5-number summary, but it also gives you the mean. Okay. Again, things that I do this every single day, every single time I do an analysis, I do summaries all the time, basically it lets me numerically see the values in a variable, okay? We're going to see tomorrow several different ways in which to visualize these data via plots, via more programmatic understanding of data, processing of data, doing things by groups. There'll be a lot of that we do tomorrow using the tidyverse. So that's sort of what I had for this evening. I'm more than happy to open the floor to Q&A. How's our chat doing?
I think pretty good. I think we've been covering the questions that people have been asking.
Okay. Are there things that people had that wanted to? Okay, there's a good one. Lily, what's the colon mean? That's a really good question, Lily. Okay, so there's a few different ways to access. So if you look at a package, these are all the functions within that package, okay? Normally, to get at all those functions in a package, you have to load the package. So we do library psych. Once I do that, then I have access to all these different functions. It loads it into, it's in the environment, I can immediately use it. If I don't want to do that, if there's a specific function that I want to use in a specific package, that's what that double colon does. So if I want to use the psych version of describe. Okay, I can get the specific function from a specific library without necessarily having to load the library this way. That's what this double colon stands for. It's give me this function within this library. Why would you do something like that? You do this sometimes because different packages have functions with the same name. This is more common than you might think. For instance, there's a function. There's a function called car recode that is used for recoding variables, like reclassifying variables, giving the different, like combining values, recoding of variables. There's also a recode function in the dplyr library, and they do very, very different things. Okay, if I were to load this library, it's going to automatically cover up any other functions that have shared names. Okay, so it's going to mask it. And most libraries are pretty nice. They'll tell you that. So if I do library dplyr, it gives me a message. Attaching package dplyr, the following objects are masked from the package stats, filter, and lag. So if I wanted to use those functions from the statistics package, I can't do that anymore. Okay, unless I do the double colon. Then I can directly use that one instead of the dplyr version. It also masks something else from the base package. It masks intersect, set diff, set equal, and union. So, every time you load a package and there's a conflict, it's going to print out a message like this. But if I know that I want to use a specific function from a specific library, then I can use this double colon notation. Okay. What's the $? What's that for? It's to access. Okay. Yeah, it's how do you access a specific variable within a data frame. So for instance, if I want to do a summary of PRB2, if I want the crude birth rate, I'll do $CBR to get access. This allows you access to a specific variable in a data frame. Okay. Thank you. Okay. Can you access? So typically at this level, we're only going to be writing code. In this program, we write code. That's part of being instructed in how to do all this stuff, and why we're doing this to start with is to show you how to do that. We don't use SPSS in this program. We don't use point and click. We write code. Mostly that is to ensure that any analysis that's done is repeatable. I can pick up the code that I ran last year, like I mentioned earlier, run the code again, and it does the exact same thing it did last year. I can't do that with clicking buttons. That is impossible. And that's something that as you move into sort of the learning how to do analysis, it's sort of an undergrad or master's level to doing PhD level research, you're going to want things that are inherently repeatable. You don't want to go back and completely start the cookbook again every single time you do an analysis, because you're going to throw away all that hard work that you put in. By writing code, that preserves the cookbook. That preserves exactly what you did throughout the entire process. Okay, so I had this last few minutes here set up for Q&A. So I'm more than happy to open the floor to any questions that anybody might have about housekeeping issue. Do you keep a list anywhere of what packages you've installed? Is this order of loading them important? The order of loading them can be important because if the libraries have the same function it'll use the one that's loaded last by default. Do you need to load them all every time you open for? Yes. Every time I start, like if I close this R session and I open up a new one, I'll need to, sorry, share screen. If I open up a new R session, it's going to start with nothing loaded. Okay. I don't have to install the packages again. The packages are already installed. That means the installing the packages downloads it from the web to my computer. The loading of the package needs to be done every time I start R. So a lot of times, let me show you a real file. So where's that? Okay. So here's some code I was using to do some stuff with Rstudio this morning. Oftentimes you'll see in people that do a lot of R coding, they load all their required packages first. Okay, so they sort of establish that part of their code as where they load their packages. Okay, and then afterwards they're going to be using those functions of the packages as they need. But most of the time, whenever I'm writing a script to do a big analysis, I will load everything that I need up in the front. Okay. Is there a list of packages somewhere? Yes. So if you go down here to this window, the files, so on mine, it's in the files window. If you find this packages tab, this is going to show you all the packages that are installed on your local computer. Okay. And I have lots. I install, every time I install R, I install like hundreds of packages that I just do it every time. So these are all the packages that are installed on my computer. So this is where the list of packages exists. I think there's a function called installed packages. Yeah. So there's a function called installed.packages that will print out for you all the packages that are currently installed, which in my case is a ton. Yes, Jyoti, I'll as soon as we're done tonight, and so Zoom will process the video, and as soon as I get the link from Zoom that the video is processed, I'll send it out to everybody. I don't have, if you didn't get an email from me today, that means that you didn't sign up for the class. If you did, that means I don't have your email by default. What I'll probably do is I'll just send out the video to everybody on the student email list. Okay. And Raheli, I'll know that you're on there if you want to see the video, and Samuel, if you want to see it, I'll send it to you too. So I'm going to be, I'll send these out when I'm done. Other questions?
Dr. Sparks, I remember that you used to send us like a link with all the packages, but that was course specific, I think.
Right.
Great. Yeah, I just wanted to mention that.
Yes, so that's a good point. So for all the classes that I teach, they're in the syllabus, I have a script that tells you, I've got a repository over here called R code. And in here, there are these install first functions. So for my class in this semester is 7263. And this is the code that installs the packages that I use in the class. So the idea is that once you have R installed, you can, it's really kind of neat. I can copy the URL. I can go over to R and type source, give it the URL, and it'll run. Oops. Oops. And I'm even nice enough to give you a little message. This might take a little while. And it's going to install all the packages that I assume you have loaded for the entire course. Okay. Now, this is something I started doing a few years ago. just to make things repeatable. Like, look, when we're starting stats 2, these are all the packages I assume you have. Because the last thing you want to be doing is trying to repeat something I do in the notes and something not work because you probably don't have a package loaded or something like that. So yeah, thanks, Aisha, for bringing that up. Other questions?
Dr. Sparks,
Yes.
how do you clean the console?
Clean the console. Good question. Control L. Control L, that's a Linux command. So R and Linux are kind of kindred souls. Control L will clear all the previous output from the console. There's a cheat sheet. If you go up here to help in Rstudio, there's a bunch of different cheat sheets. One on the Rstudio IDE, it kind of went through what I just did, the Rstudio version of this. dplyr, ggplot, different things like that. Our markdown, which we'll talk about another time. Lots of different cheat sheets to kind of give you commonly used commands. Yeah. What else? Okay, well, Selena, if you say if you sign up for the one, then you signed up for both. I got your email. There's only one sign up link, so that's not a problem.
If I didn't sign up for today, though, should I go and fill out the link?
Just so I have your email. I mean, I'm probably going to be more generous than not. That's sort of one of my character flaws. I'll just send it out to the whole student list probably, but if you wouldn't mind, go ahead and give me your email. That'd be great. I'll give you all the secret stuff. Okay, what else?
Hopefully this was helpful for all the first years.
Yeah, hopefully this is, my goal here isn't to, you'll never be an R expert. Okay, I've been using R for 20 years and I learn something every single day, and I'm not pulling your leg on that. Every single time I start something, I learn something new. I don't consider myself to be an R master by any, I don't even know what that means. I know how to do a bunch of stuff, but every single day on like Twitter, I see all these smarter, hipper, younger people than me doing all this wonderful stuff. I'm like, wow, this is amazing. I'm going to use that. There's so much to learn, and you need to be confident that you can learn what you need to learn. You'll never learn it all. You need to learn what you're going to use. Okay. And most of you are going to enter the first semester stats class, and you're going to be using a lot of the functions we just talked about. That's going to be helpful for you, especially tomorrow. I think basic data processing with dplyr and basic visualization. Those are going to be tools you will use the entire time you're in the program. So getting a good fundamental exposure to that is really valuable. I mean, the stuff like Raheli and I were making plots this morning, and, I think they're pretty nice looking, and it's not plotting 101. There's a lot of other options you can feed in there, but even, a basic plot is really easy to make in R. A basic plot that looks 100 times better than a plot in any other statistical software package is really easy to make in R. It's really possible to make the economist level data visualizations that just look amazing in R. But you don't start there on the first day. Okay. But you can't get frustrated when you can't make an economist level data visualization on the first day either. Start with histograms and bar charts and box and whisker plots. And once you understand the basic fundamental structure on how that's done in R, the world's really your oyster. Can hipsters teach? Maybe, I don't know. I'm too old to be a hipster. I don't know. Okay. Okay. If that's it, then I think we did pretty good on time tonight. I'm pretty pleased with myself. I didn't go off on a rant or anything. So as soon as the links processed for the video, I'll send that out probably later tonight or in the morning, and I'll see you all tomorrow. And if you know somebody who's not here, who might want to see the content tomorrow, tell them to come, give them the link. I don't care. It's virtual, anybody can come. All right, so we'll see you all tomorrow. Have a good evening. This is great practice because this is what your classes are going to be like. So about the time. All right, we'll see y'all tomorrow. Take care.